Waiting line and queuing theory solved example. I consider this example, I just designed it right now just to explain a few points how it's happening. So we have people arriving at system 1. We have two systems in sequence, system 1 and system 2. People arriving at system 1. One person every 15 minutes, and the system 1 is serving people at a rate of one person every 12 minutes. So after system 1, one person leaves the system every 20 minutes. So whatever that means, we'll see in a bit. And one person joins the system every 30 minutes on top of the one who moved from system 1 going to system 2. And system 2, it serves the people at one person every 10 minutes. Okay, so the first step to do, we have to study the system, and the systems, they are both separate, they are independent, although they are in sequence. But when we study them, we have to study them as system 1 alone and system 2 alone. So let's see how this happens. So we have, the first step is to calculate lambda and mu. Lambda is the arrival rate and mu is the service rate. Lambda, one person every 15 minutes, and as we said last time, we have here always to have the same unit of time, which is 1 hour, and here the same unit of time we'll see in a bit, which is 1 hour. Okay, so if one person every 15 minutes, that means 4 people every hour, and the service 1 every 12 minutes, so it's 5 every hour. The fact that arrival rate is less than the service rate, so the system is okay, so we could proceed in the system. And the reason why, because if the service rate is, I'll show you in a second. Okay, if the service rate is if the arrival rate is more than the service rate, so there will be an endless queue. The queue will build up, so we need more than one person to be servicing the job. Okay, so let's see how this will happen. We have lambda equal mu minus lambda equal L equal lambda over mu minus lambda. So we replace lambda by 4, mu equal 5, lambda equal 4, so 4 over 5 minus 4 equal 4. On average there is 4 people in the system. LQ equal lambda mu times L, 4 over 5 times 4 equals 3.2 in the system. W equal 1 over mu minus lambda. As we said, mu is 5, so I need to repeat this. L is equal average number of people in the whole system. قديش في ناس بكل السيستم. LQ is the average number of people queuing in the system. قديش في ناس waiting in the queue. قديش في ناس standing in the queue. W is the average waiting time, average time spent queuing in the whole system plus being served. يعني قديش أخذ وقت, how much time it took us waiting in the queue plus to get served. يعني how much time it took us on average in the whole system. WQ هي ال average time in the queue. Rho 0 هي lambda over mu. Okay, as we see it here, which is the idle, as we could see it here. Okay, هلا for system 2, lambda 2 is equal, all the people are leaving system 1, they head to system 2, which is 5 over 5 people per hour. We have here one person leaves the system every 20 minutes, so 3 per hour minus 3 per hour, and one person joins the system every 30 minutes, so it's 2 per hour, as you could see it here. Okay, so 5 minus 3 plus 2 give us 4 per hour, and the same we're gonna compute the same way. And we have the service as one person every 10 minutes, so 6 per hour, so 4 over 6, so the system is doable 2 over 3 busy. يعني 66% of the time the system is busy, the person is busy 66% of the time, and 33% is idle. If this value is more than 100% busy, so we require another person, and this job cannot be done, so we have to hire a second person. We only can study the system if the percentage busy is less than 100. يعني ما في يكون he is busy more than 100% of the time, therefore he has more jobs than he could handle as a person individually, and it means we need to hire a second person to help him. So the same way we do L2, LQ2, WWQ, بنطلع الvalues هون as it is. Okay.